How's it going, everyone? Eulier Gonzalez again, looking at the front-end system design, which is a course taught by Yves, right? Uh, he works as Meta, and also he previously worked at JetBrains for over 3 years. So the idea here is that UI engineers must understand the fundamentals of how they can now build complex, large-scale apps. So this is by looking now at first at how the browser works, how it treats the HTML, and how now the formatting context has a relationship with the position context, and therefore the way of how now that is connected to the graphic UI or the GPU as a way to be able to identify is what will happen when you are creating an HTML, when you're using a specific CSS class, and how you can now harness is the full power of the GPU when it comes to build now this UI uh, web applications. And then a little recap about the DOM API, so how you can actually retrieve elements using these new techniques. Because after all, it is like a shovel. You can actually get elements out of that. Also look at what are the ways of how you can build now more complex UI patterns using now the observer APIs. Now have a more practical approach of how you can actually do that by creating a virtualization list. And then by understanding and also look at what is the application state, which is the way of how now applications on the front end actually not only pull data, store that, but manage that as a way now to provide these more complex UI interactions, but also the network layer as well as the protocols that we can have access to. And last but not least, how you can manage is assets, specifically HTML, CSS, and JavaScript, fonts, image, right? And then how you can now build a system design or a front-end system design uh, like a social news feed. So all of this is to actually gain some perspective of by looking at how you can now is harness the full power of the CPU through the browser using a specific directive and understanding is this high level concept you can now build is performance UI applications. And I think this is something that at the end of the day, especially if you want to build now more intense driven application like that, uh, that actually is, or more intense GPU application that provide much more interactivity than ever. It is required you to understand is the fundamentals and then understand the goal, the end goal of doing all of this. So because of that, as I mentioned before, this course is structured on the introduction as a way to understand what is the value proposition of how we can do this kind of thing. Similar to the core fundamentals, as I mentioned, is that how the browser works and how the browser now treats the HTML and all of that kind of concepts that it will be laid down the foundation of how can we ultimately interact with the GPU, right? Through all of this layer of abstractions. The DOM API, Web API for complex UI patterns, virtualizations, application state and network connectivity, web application performance and system design interview, which is building a social media apps and what are the things that you need to do to come up with that. So in today's video, I'm gonna take a look now at the core fundamentals, dive deep into this as a way to understand and be able to describe that when you need to explain that to other college, PM, business people, shareholders, the founder, and other people involved as well. in a way that I make that meaningful to others. So, um, because well, this is the introduction exactly. Because the front end design systems uh, is one of the aspect of how you can build applications. So you have now the backend, the API, and the front end, and now how the front end per se uh, allows you to do, or is about fetching data from a server, then store and manage that data to create now more complex UI patterns. Uh, so, for example, some animations, or also how you can now actually make fit thousands of elements in a small screen, uh, and how you can now manage all of those assets that the browser is downloading in a way that is efficient and effective. So this is part of the course plans. Okay, as I mentioned before, I briefly described that, which is to me the way of how you can actually make sense of something, uh, especially especially as you now understand more complex concepts, right? So, for example, in this case, the core concept, as a way to first understand, is the box model. Everything in CSS has a box around it, and understand how this box work is fundamental as a way to see how you can create now more complex user interface, uh, and how this box interact with each other. So that's why we look at the box model, uh, the box anatomy, which is you get now the content, because this is now how the browser treat elements, uh, is now place that into a box. Okay, where now this box is, well, you got the content, you got the padding, you got the border, and you got the margin, right? So this is the anatomy of this box, and this box have two characteristics. So you have either uh, box size and box type. So the box size is how you determine is the width, or how the browser now determine is the width of this. So you have now intrinsic values, where now the content of this element is determined by its width and height, intrinsic values of the content. All right, and the extremes, or yeah, and the restrict values, which is now imposed by specific rules. Uh, yeah, which is imposed by specific rules that it can be applied to this. Whether you specify as the width and the height of the content of this element via CSS, or based on a patent class that you modify. Yeah, exactly. Or based on the behavior, or based on the behavior, or in this case, no, you're gonna obey. Okay. Or yeah, the restricted, which indicates that the box size is governed by a set of rules. Interesting. Uh, so this restrict is a set of rules that indicate that this boxes is governed by a set of rules. That is that flex or grid, which is when you use the display, the percentage of the pattern size. So now this content will be is the percentage of the pattern size, the width, all right, the aspect ratio, property of the image, and the presence of other children in the DOM tree, right? So this presence of other children in the DOM tree is like uh, if this is set of rules, exactly, if this set of rules now follow one, or if this restrict follow a set of rules for that. You know what I mean? Mm-hmm. 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 No, okay. Oh, okay. Oh, okay. So the constraint by the padding element of other boxes through mechanisms, because it's now the padding elements that now set up particularly rules to them based on the flex or grid, the percentage of the patterns, the aspect ratio, or any other children that the pattern container has, and how they're going to behave. So with that, and we look at the box type, where here you can have is anonymous. I didn't know that thing exists. So you have anonymous, you have inline, and you have block. So the block is something that you can specify is by display or inline, and there are several type of block box that fall into this category. So you have now the address, caption, headers, HR, list, main section, canvas, video. So all of this follow is this type of box, which is a block. What does it mean is that now the browser render any block element, and it'll take the 100% of the parent container width, and the height will be determined by its intrinsic size. This is all about from the browser perspective. Okay, so when it identifies this particularly tag, all right, or you can apply this particularly uh, CSS property, okay, it will now create is this rule that is going to apply to this context. It's going to create a box. It's going to identify which type of box is, in this case, block, and then now because it has several rules that apply to this block, it say, okay, now this particular element, their width will be is 100% of 100% of the patent container width. All right, and the height will be now the intrinsic size, which is the content type or the content height. The browser will going to now render all of these elements from top to bottom, and now it participates in something called block formatting or blocks context formatting. I didn't know that these things exist. All right. So blocks context formatting. However, if the browser finds some elements that are not wrapped inside of a particularly HTML tag, okay, so what it's going to do is to, well, put that in an anonymous box. Okay, most of the time we don't use this one, but this is a way of how now the browser actually put a box around this. Okay, because what is relevant for us is to look now at the inline and block. Okay, we look now at the mathematics of the block elements of how now it calculate, how now the browser calculate is the width of that element in block of the block elements. So if you specify a particular property, or which is now, hey, the box size will be the content box, he will now take, so if you need to compute that, you will need to actually take in consideration the margin. You need to do that math manually. So the margin left, the margin left, the bottom left, the padding left, followed by the content, plus the padding right, border right, and margin right. So as a way to prevent and makes the computation much more simple, we use something called box size border box as a way to now tell the browser, hey, now the width you go on the width going to include is the padding as well as the border. All right. So all of that will be is the content, and we just only want is to calculate is the margin left and the margin right. This is some sort of preset that you put in there, right? Mm-hmm. It's some sort of preset that you put there. So this is now how, the way how the browser actually uh, compute, or you can now compute is the width. All right. When it comes to the inline elements, so when the browser detects each one of those particular elements, whether it's an anchor, BR, bottom, image, input, strums, var, p, something that is not here. That's interesting. That is not here. Anyway, but p, span element, script, label, select and text area. All of these elements, now the browser, when you look at this, it treats those elements as an inline element, which is this type of box. So the key characteristic here of this inline element is that they render like a string or next to each other, starting from left to right, or flowing from left to right, and then top and from top to bottom. So this is the way of how now, when the browser detects each one of these elements, it say, hey, this is an inline element, or this element actually follow is the inline formatting context, which is when you now are explicit, uh, when when you as a author you explicitly tell the browser, hey, this element, uh, it is an inline. I want you to display that an inline, and all of it is child components. So they generate inline level boxes, right? And they participate now in this inline formatting context. Again, something that I was new that the browser actually do that is say, hey, you can think of this as pretty much like a record, okay? Hey, I have all of this record. I have now the record of the block context, blocks formatting context, okay? And it's this. And now I have another table with all of this inline formatting context, and all of these elements that actually fits here. Uh, Also, the inline elements has a specific mathematic as a way to calculate is the width. All right. Where here you can is, because now width and height are completely ignored in inline elements. The browser said, I don't know what is this. The browser ignore width and height, and as well as the vertical margin. That's not. So inline padding does not alter the height of the inline element. So if you want to calculate is uh, the width of this inline element, all right. Uh, Here you need to actually go through each one of those elements, and if that particular element you're trying to add in some padding, uh, what it's going to do is to go out the baseline, so it doesn't alter the height of the inline padding. Okay, so in other words, it's like when you're trying now to put an element there, it will not show that as problem. So so we got now the non-con. This is not the area where now this element is not rendered, because we have a baseline where all of these elements actually fits in. And then we look now that we talk about a lot of these contexts, okay, formatting context, block formatting context, as well as inline. Uh, the idea of talking about this formatting context is that now the browser isolate them, so it shields this context from external rules or from external context, Okay, so now that the browser have this record of elements here of this block formatting context and inline formatting context, so now the browser can isolate them, so to prevent the other rules applied to that. It is scalable because by introducing new rule set, it is as simple as just adding a new context. All right, so you can have as many contexts as you want, and this is a lesson that you can learn from the browser here. It's like isolation, creating a context allow you to now make it much more scalable, and by putting a context, a set of rules, you make it predictable. So now the browsers can identify what are these. Mm, so now the browsers can identify what are the rules applies to this. All right. So now the browser can look at that. Hey, what are the rules that are applied to this? Exactly. So hey, what are the rules that are applied to this? So the idea here is by understanding is the formatting context and what are the benefits of having now this context here, which is not only provides isolation by any context or shield from external rules, from rules that are from external context. All right, so they pretty much like in scope. This is isolation. It is scalable because now we can is adding a particular context to any elements as we need it, and is predictable because this context now contains a set of rules that is going to apply and make it predictable to put these elements. So with that, as a way to now understand a real life example of the uh, block inline and how you can mix that, which is this, all right? The formatting context, like so, is similar like this. We look at this real life example and the HTML start as a block. So the browser say, hey, I'm gonna treat this element as a block, period. This is a block, all right? Yeah, so this is a block. All right. Okay. So this is a block. All right. And because of that, now after that, it create now a new uh, block formatting context where you say, hey, now the body creates a new one as well as the H1. So the H1, so the browser says, look at this and say, hey, I'm going to create now a block formatting context. Okay, so any elements defining that will follow is the rules that I mentioned before, as well as the mathematic. Okay, similar to the unordered list or this particular tag. Hey, I'm gonna treat this as a block type, and the similar to the list or the li list items. So the browser detect that and say, hey, I'm going to treat this by default as a block, but because now we indicate explicitly, hey, this is this type of this place, or this particular the way of how you're going to show this element or this block, or the type of block for this item, it'll be now an inline block. So it creates now this inline formatting context that goes with all of these rules that we defined, that we see previously. So the width and height doesn't apply, vertical align as does not, and elements here are put in from or the flow of this are from left to right and from start to bottom. Similar to this, all right. And then when you reach the section, you say, hey, because this is the section, you're gonna create a block formatting context. But wait, here the author, the developer is telling me, hey, no, this actually will going to follow is the flex uh, formatting context. So now their elements is going to be present as row, which means that by default, the flex follow is this inline formatting context, somewhat, right? But putting all of these elements like in a string, so next to each other from left to right. But here you're telling us that, hey, put all of these elements like a block type. But again, this is a way of now the display flex with this property actually work. So the paragraph here actually is creating is this inline content. This inline, so by default paragraph create is the browser detects this and say this is now an inline formatting context similar to this, right? No, I think is yeah. Flex direction row. I mean, it's row exactly. Uh, and here you are putting is these elements like it is, and because the browser treat elements as an inline formatting context, whatever we put inside of this is going to be stacked as follow that particular rule, and that's exactly what this thing is actually doing, right? So understanding this, the formatting context, and when we take a look now how the browsers want to understand all of these particular rules inside of this context, which provides isolation, which provide is isolation, scalability, and predictability. Okay, so now the browser needs to know how to put those elements on the screen. This is the browser positioning system. So the browser by default have this thing called the normal flow, all right, where it put all of these elements right to left, and there is a very interesting video of how he do that, especially from Wikipedia. Let me see if actually we can bring that up here. YouTube here. I just want to bring that up. Wikipedia rendering. What I think is browser rendering. Browser rendering. Yeah, it's quite hard to find that. I mean, it's layout. Yeah, that's right. Oh, this is Geek of Reflow. Because you can see all of these elements are put in from left to bottom. This is the normal flow. So you start from start to bottom and then apply all of these elements then left to right. Now see it's left to right, and this is the way how now exactly is the Wikipedia page is rendering, right? And I think this is a very interesting video. I don't know, 15 years Gecko Reflow visualization. You know, this is the way of how now the browser then position that properly. That which is fantastic. Which is fantastic. As you can see, it's now actually putting all of this, and then a box here, and then feed that content as a way to position that. And all of this is the mysterious things that the browser is doing, but it's so blazing fast that we ignore that it's doing. And then position that and then reflow that. It's interesting. It goes now to the parent root as a way to now provide that. That is quite interesting. Very, very, very interesting. Holy moly. Holy moly. Holy moly, bro. I think this is a more interesting video than the Wikipedia. I googled that coin Japan. So this is just to so you can think, so you can now imagine what it's doing. Very, very interesting. Very, very interesting. But again, the point of this is that once you're able to understand this, okay, deeply understand this, the normal flow and all that kind of thing, and how now the browser actually position all of these elements, and how you can actually break that, because you can put this you can set the normal flow to be like from right to left, or from right to left, from right to left, sorry, and then from so from uh, so from left to right, to the left to right, right? So because of that, because this is now how we can actually, the browser is positioning all of these elements, we can change the normal flow using is the position of that, which means that this is an static, relative, absolute, sticky, and fixed. So most commonly way to actually position elements outside of the normal flow is by using relative and absolute. By default, it use static. Okay, so what happened when we use position static? It actually follow the normal flow. All right, uh, exactly. It actually follow the normal flow, which is from putting all of these elements from left to right, right? Putting all of these elements from left to right. So if we use position relative to a particular element, okay, um, according to the normal flow of the document, the offside applies relative to itself based on the value of top right and bottom left. So an example of this, it'll be by taking now, take a look at the, okay, this is position relative. Is there any way that we can actually go with that? That's right, with this one. Oh, but I think no. Okay. No, I don't think actually he's able. Oh my god. Unless we got in the resource. And we don't have that. That's silly. That is silly to me. Core slice. That's right. Is this one. So you can see here, browse positioning flow here. All right. Browse positioning flow. Let me actually is make it here, right? All right. And the other is position relative. Exactly. And the other is position relative, which is like this. So now here, okay. Now here we can say is that once you tell to an element to put in a position relative, you're telling to the browser to treat these elements out of the normal flow. As long, okay, so not exactly. So you either treat this out of the normal flow by creating a stacking context. As long as you use C-index, C-index, and it's not author. So for example here, we are now have is this, and we can actually move the element, which to me is like I pretty fucked up. Let me actually rerun this. Is there any I rerun this? Okay. So this is how you can get this offset from the key, opposite from key, counters, opposite counter key as well. And when you handle arrow, hey, if you detect is a particularity of these elements here, let's say arrow left, arrow right, and arrow down and up, for each one of these cases, this is what you're gonna do. Right? You're gonna get and replace the arrow. You're gonna get that key and replace the arrow with nothing and put that to lowercase. Since this key, it contains the event key, alright. So this is the select ID. Interesting. Here you're now is calculating is the offset key, the opposite key, current offset CSS, and current offsets offset. After you define all of these particular variables, offset from key, select ID, okay, exactly. After you identify what is the property that you want to apply, okay, you might wonder to not only add that, but also apply is the minimal, okay. So for example, offset from key, like so. You're gonna get that element here, opposite from key. You're gonna get that element from your hash map, okay, and then going to calculate the style from the box, which is a class that you must define, or okay, the constant here, the box that you want to move, and then you're going to apply is this offset key. Hey, this is the style that I want to apply, which is in this case it'll be is the offset key. So for example, you put up, this is what I want you to do. So box style up, so you set current offset CSS, and then you actually apply that. All right, then you're going to apply the current offset CSS. Or otherwise is 0, which is initially. A new offset by actually calculating is the amount of that you're going to apply to that, to the offset key by the new offset in pixel. You unset that. You have now your counters that are updated. The whole point of this is that now you are applying is to this relative object. Look at how imperative is all of this. You're explicitly telling what you have to do over and over and over and over and over and over. Yet you explicitly have to tell what to do over and over and over and over. Okay. In this box, which is now relative, okay, and relative actually is you're telling to the browser, hey, I want you to treat this element, as you can see here. I want you to treat these elements on all of the child as position. I want you to treat all of these elements, okay, on the position, and I want to apply an offsets. Offset apply relative to its cells based on values to top, right, bottom, and left. The offset does not apply the position of any other elements. So by actually telling to the browser, hey, this is a relative, I want you to not treat these elements in a way that I can offset that with top, right, left, and bottom. Makes sense. Makes a ton of sense. But the offset doesn't affect the position of other elements. As you can see here, so it doesn't affect the position of all other elements. Wait, what? Interesting. Okay. Okay. But the idea here is that it's actually very, very it's actually but the idea here is that it doesn't affect other elements here. You may wonder how the browser doesn't know that don't affect other elements in the DOM. You know, when you specify is the position, when the browser need to position in an element into the DOM. Glad you asked. So before going into that, we need to know that something called containing block, which is now the way of how when you indicate or you put a position, relative or absolute, you're now telling to the browser, hey, this element will be now the containing block for all other elements inside of that. Which means that now you're going to apply is the rules for this elements. So all of the elements inside of the blocks is going to now behave by following is this position. And the position absolute, the element now is removed from the normal document flow. So for example, if we say here absolute, I can change this. I did this in Copen. So for example, if I say something like, hey, and we need to now change the to absolute, right? Now look at this. Starting to calculate it from, so here there's an interesting thing here. Why actually is jumping here? Because it's actually removed from the normal flow and going to in that position. When you indicated the position, actually it was removed from the normal flow and is going to position to the closest position relative ancestor if one exists. Otherwise it is placed initially at the initial container block. All right, so in this case, because this is placed to the initial container block, which is now the container, and the container in this case is actually is 20 view for 20 view, light grade, and that kind of thing. All right. So for example, if we add now a come on. So for example, if we add now is this box here, all right, and since diff, in this case, let's gonna call this diff as, say, this will be the second container here, container 2. All right, where now this will be is, because the div is now follow the block formatting context, we're gonna make it yeah, we're gonna put this yeah, we're gonna put this as, instead of to take all the available space with only the 50%, right? Say, hey, I want you to now is make this position relative. Say position relative. All right. I want you to modify this to be now rendered at the 50-50. So the top will be 50 pixels and the top and right, top and left, top and left 50. Okay. So now these elements, we take all the available space, is going to be rendered now 50% down from the top and 50% left from that. And because we put now this relative as an absolute, let me actually consider that relative as a way to prevent any misbehavior. And absolute absolute here, which will be position absolute. Okay, we are telling now the browser, hey, treat these elements as I'm telling you. Okay, treat these elements as I'm telling you. All right, and now apply is the container 2 class here, container 2, right? So as you can see now, the element is put here because now this container, that it takes all the available space from its ancestor, right? It's a now this is started at 50 pixels there. For example, this. All right, so because also container actually is center elements, I'm assuming that container here is display flags and center that. That's one of the reasons why I put in this element here on the center. And we're telling now, hey, I want you to render that element 50%, 50 pixels to top and left outside of that. So the whole point of this is to see that now this particular box here, especially when you tell the browser to treat these elements and as an absolute, it will go to the it will be removed from the normal flow. No space is reserved for the elements in the page layout. Okay. Exactly. It will be removed from the normal flow. Mm-hmm. So it will be removed from the normal flow. That's one. Okay. So it'll be removed from the normal flow. Mm-hmm. Sorry. So it'll be removed from the normal flow. There is so no space is reserved for the element in the page layout, and if it is positioned relative to it, it is going to position relative to its closest ancestor if one exists. Otherwise, it is placed relative to its initial container block. So, for example, if here we don't actually is initial container block, we can say that this container now is a display block. All right. So which means is that we don't actually set the position. It is going to be positioned. Mm-hmm. That's interesting. But again, it's important to actually put that. It's important to actually put the position because by default it's static, but it's important to put the position because you are telling to the browser how to treat these elements. Mm-hmm. You're telling to the browser how to treat these elements, and it should follow the normal flow, or if you are going to use now stacking context. So the final position is determined by the value top, right, bottom, and left, and this position creates a new stacking context where C index value is not outer. Pretty much like this, the value creates a new stacking context, whether it's for position relative and for position absolute. The browser create now a stacking context with C index with where the C index value is not outer. So the thing here is that the way how now the browser actually position elements is by following the normal flow, or if you're telling to the browser to this particular element going to be stacked or going to be positioned relative or absolute or even fixed, okay, it's going to create now a stacking context for that, where now in the case of relative, the top, bottom, left, and right position actually are applied to the element itself. Okay. In on absolute, the space is not reserved, and it's going to, yeah, the space is not reserved. Box 1 was removed from the normal flow and placed in a separate stacking context. So you got is this. So the element is removed from the normal flow, the normal document flow. So no space is reserved for the element in the page layout. Exactly. And its position relative to the closest ancestor position relative or to the initial contained block or to the initial containing block. And that's one of the things we look at this, because it's now putting at the initial containing block. You know, so this is something interesting as a way to understand now how not only the browsers um, have this, not only the browser how not only how the browser apply or treat HTML elements, which is one, but also how it actually position elements using the position, and how now the formatting context, whether it's blocks or inline formatting content, as well as the stacking context, okay, uh, is now the way of how we can actually is go to the next topic, which is performance. So the stacking, the TLDR of looking at the position system is that not only that we have the ability to tell the browser how to treat these elements by its position, whether it's relative or yeah, whether it's relative or absolute, but also create a new stacking context. And whether this is relative or absolute, you're going to apply certain rules to these particular elements. So far so good. That's quite interesting, because if we use position wisely, we can achieve isolation and performance optimizations. So, of course, all of these elements that we use position, now the browser creating a stacking context for them. And this is stacking context, especially if you're using position relative or absolute. Uh, this particular stacking context that the browser create that is a key prerequisite for optimizing and minimizing DOM updates to the DOM. You might wonder why the browser does it needs to create a stacking context. Okay, so because now we have a way to represent different layouts, something that UI designers are quite familiar to that. So now you are actually mm-hmm, 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 yep, that's right. Yeah, that's right. All right. Mm-hmm. So it's important to understand why it's important to understand that when you are creating is when you're telling to the browser to treat these elements in a particular position, whether it's absolute or relative, you are now putting these elements outside of the normal flow, which start from left to right and top to bottom. Uh, and the browser creates this stacking context. We're going to apply certain rules to them. So for example, in relative, well, now you can the offset is applied to the element itself, top right, bottom left. And this won't alter other elements in there. Uh, and when you apply now the absolute, the space is not reserved. Okay, the space is not reserved. Makes sense. Okay, so the space is not reserved Hmm. So the space is not reserved for that, and it's going to put those elements at the closest position relative elements or the initial containing block, right? So the idea here is that when you are now using is that you are now looking at the absolute, and the absolute is going to look at a reference, which is usually from the closest nearest, from the closest position elements, or the initial containing block. So this create now a new stacking context. And again, you might wonder, so box 1 was removed from the normal flow, similar to the box 2. Since a later layer is always stacked above the previous one, box 1 is positioned behind box 2. This is as a way of how now the browser is stacking all of this. If you take a look at this, all right, leave the page and actually edit this. So you can see actually what it's doing behind the scenes. You have box, red and blue. Blue is actually showing like those. And, well, you are now treating those elements inside of this as relative. You're telling, hey, now put these elements relative here, and all of these child apply that to. That's quite interesting. That's very, very interesting. And all of the childs inside of that box, oh, it's because the box is absolute. Okay, you are creating is a new stacking context. All right, all right. You are creating is a new stacking context. So for example, if you take relative, that's right. But as you can see now, the box 1, but as you can see, the box 2, since now all of these elements inside of this box actually are relative, it's actually it's creating all of these stacking contexts, one after the another, right? So for example, if you say something like this, if you change the order, okay, like this, if you change the order, all right, now the box 1 is going to show above, or above that, the red one here. Oh, because it's showing its opacity, but if we actually don't put opacity here, all right, and if we move that to that, that's right. And if we make that now the box to position absolute, as you can see, and if we add now this 20 pixels, as you can see, is the later actually is going to now overlap the later. So the last tag that you define will be overlapping is the previous one. Using is the absolute. But the whole point of this is to see how you now, by telling to the browser how to treat these particular elements, and whether it is a block or inline type of box, and why you now putting the position of this, or telling to the browser to position these elements using is relative or absolute, and how now that creates a stacking context, and how inside of this stacking context you can create now layouts, whether it's following is the the block formatting context, or the inline formatting context, flex formatting context, grid formatting context, That's quite interesting. You started to see the relationship of all of this. All right. And you may wonder, why do we need to take a look at all of this stacking context? Because when we engage with 3D transformations, absolute position, or any action that moves the elements from the normal flow, we are now creating is an additional stacking context. One, so 3D transformation actually create that. We're creating an additional stacking context. The browser used that stacking context as a way to represent the layers in our layouts and do performance optimizations to that. So elements removed from the normal flow are placed into a stacking context, and modification to each one of these stacking contexts do not impact any other elements within the normal flow. Exactly. So all of these stacking elements that we define, all of these elements inside of the stacking context, whether it is, we can define its layouts like block formatting context, inline, okay, block formatting context, inline, um, grid or flexbox, all of this, all right. Um, mhm. So all of this all CSS transformations as GPU accelerated, and all of CSS transformations are GPU accelerated, meaning the browser doesn't need to recalculate the DOM tree. Again, all of the CSS transformations, which is now creating is a new stacking context. The browser doesn't need to recalculate the DOM tree when such operations are performed. This minimizes the reflow cycle. And you may wonder, what in the F is the reflow cycle? Glad you asked, because I don't know what in the F is that. There's a reason why we are looking at this. All right. Really? Let me ask a question here. Is reflow the same as is reflow in the browser the same as the no, because reflow is, oh no, no, is the same as the critical critical rendering path? No, it's not. Reflow and the critical rendering path are related concepts in the web browser to the entire sequence of steps that the browser takes to convert. Exactly. Mm-hmm. So, all right. Okay. Browsing documents. Yes. Okay, reflow. So when the browser, exactly. So when the browser reads the HTML, it creates a DOM as a way to represent the HTML tags uh, in a data structure. Okay, to work with that, similar to the CSS. As it parses, it creates the CSS object model. So far, so good. Both of this is now looking at the anatomy of that. Again, recap that. So both of this and creates as it parses it and creates a CSS object. Both the DOM and CSS are used by the browser to generate the render tree, which is not a unique concept from React. It's actually using is that, and there is a reason why, for example, people in React actually reuse all of this concept from that, as well as a concept from language, like the virtual stack frame for the stack frame in JavaScript. That's quite interesting. Exactly. Which is a way, a way to represent HTML tag in an object form way. Okay. In an object form. Okay. And similar to the CSS, right? So hey, I need a represent, and this is where the representation comes. I need to wait to represent this data here because I want to operate with this data here. You can talk about these representations. So for example, on the music. So most of us, we need to find, when we are young, especially 14, 13, 11, and some of them until 16, 17, always, is that we need to find a way to represent us. And that is, whether it's from the music, perhaps sertanejo, cumbia, rock, reggaeton, the you name it, because there's a lot of one. You have Arabic, East Asian, Southeast Asian, Asian sounds, Gregorian synth, you name it. You know, and also African styles. So all of these are representations of how we can now use that, or how can we now be part of that, and then how we can communicate based on this representation. So pretty much the same, somewhat similar as on the machines. So we need to find a way to represent that as a way to then later on operate on that, work with that, interact with that. So for example, if you go to United States and if you don't know right now, if you know Spanish, some of them actually are trying to understand that. But if you go to, for example, Australia or China, and if you speak Spanish, it'll be very, very hard for you to actually understand what's going on. So you need to find a way to represent your idea into that. perhaps English might do the trick. Mandarin, if you are someone that is literate, uh, or any other middle language like that. For example, like Esperanto. All right. Anyway, I don't wanna, I don't wanna go down that path. Not at all. But yeah, that's what it is. Mm-hmm. So both the CSS and the CSS object mode are used by the browser to generate render tree by merge them. And then the browser passed down the browser moved to the reflow phase, and I get it, man, this assembly line process is something that is it's powerful. It provides you freedom, bro. It provides you freedom, and I get it why authors like a happy world, I think it is happy world, actually is a brave new world, my bad. I read that in Spanish. That's what happened. Brave New World is actually created by Aldous Huxley. Um when he mentioned so the thing is that so the thing that I brought here is that it's actually four. you know, they put now four like that, like some sort of deity, and four introduce now this assembly line process of doing things, which is pretty much what we are actually doing today, right? Which is pretty much what we're actually doing today. For transmission, for assembly line. Exactly, the best mechanism to drive flock to the fore. Human capital and expertise, raising productivity and lowering training costs. for airplane company. But in any case, that's one of the reasons why I actually bring that here. Happy brave new world, because actually this kind of idea is quite the same. It's like all of this particularly series of steps of doing stuff to produce something. In this case, is a layout, a web page to render these applications there. All right. So the reflow, and then the browser moved to the reflow phase, which is mhm. the reflow. The reflow happens exactly. The reflow happens when the browser or when the JavaScript is modifying. Mhm. But again, the reflow happens when JavaScript is modifying the DOM or or some CSS or CSS styles. It participates in the calculation of the layout. So if you take a look at the reflow here, from the Google Chrome, minimize the browser reflow, because reflow is a user blocking operation. Exactly. Reflow is the name of the web browser process for recalculating the position and geometry of elements in the document. So you participate in the calculation of the geometry, in the geometry and position of elements in the document, and position in elements of the document for the purpose of re-rendering part or all of the document. So because reflow is a user blocking operation in the browser, because because reflow is a user operation in the browser. Okay, because reflow is a user operation in the browser. Yep. Yeah, that's right. Because reflow is a user blocking operation in the browser. It is useful for developers to understand how to improve reflow time and also understand the effects of various documents property, done depth, CSS rule efficient, and different style change on reflow time. Mhm. It's a user blocking. It is important to understand how to reduce it. So for example, mm-hmm. So for example, when in a React app, the initial render, exactly. So for example, when in a React app, the initial render, exactly. So for example, when in a React app, the initial render, uh, exactly, the initial render, the initial render, the initial render of the DOM, then you provide the container, the container when React will mount the app, and do some do some modifications to the DOM uh, via the DOM API when the state change. Mm-hmm. Interesting. So the the reflow is a multi-step process. Mm-hmm. It is usually kick off by JavaScript. You can see here. Mm-hmm. Exactly. It's usually kick off by CSS. Then the DOM needs to recalculate the DOM and CSS object model to generate the render tree. Mm-hmm. Mm-hmm. Then the DOM needs to be recalculated. So then the DOM needs to recalculate. So then it the browser needs to recalculate the DOM and the CS object model, which now it needs to know where 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 it needs to know, okay, where it needs to know the position, where it needs to know the position of the, yeah, we need to know the positions of the elements. What you need to know is the position of the HTML elements and attributes. in attributes. So the layout phase so the style and layout phase, it makes sense because you have to do all of this mathematical operation. I'll do. So the style and the layout. Um, mhm. So the style and the layout is a very intense CPU operation. Mhm. So if we trigger, so if we trigger too much reflow, it will slow down our app by actually manipulating the DOM or this style, usually through JavaScript. Mhm. Slow down your app, or aka block the render thread. Exactly. So once everything is ready, we need to throw the bitmap, which is the paint phase. The bitmap, exactly. But now we need to draw the bitmap on the screen, which is the paint phase, which is the paint. The GPUs use, which is the GPU use. Mm, which is the GPU. It doesn't use CPU, which makes this pretty fast. Mm-hmm. This is a video that show how the browser is rendering that. So this is a video showing how the browser is rendering the page, the Wikipedia page through the reflow process. Okay. Mhm. So this is now the pipelines. This is example of pipeline. Okay, this is example of reflow pipelines. Initial pipeline and optimized pipeline. Exactly. So you mostly use is GPU, which means that you're using is now CSS transition, for example, or some sort of stacking context like transform that actually is now telling to the browser to use as a GPU through the reflow flow, which is the way of how now the browser uh, uh, transform all of this or to the critical rendering path, which is part of this, which is the reflow, where now you have is the HTML and the CSS, where now the browser, once the browser read all of this string and then it transform that into an object as a way to represent them and operate them. So you have now the HTML, you have the style, then the browser merged that to create the render tree, and then the reflow, which is now the way of how the browser is going to calculate the geometry and it is position of these elements. And this is usually triggered by JavaScript. Okay, so once you do that, now the browser needs to is uh, regenerate is the DOM and the CSS object model. All right. So the reflow happens when the JavaScript is modifying DOM or CSS styles, and it participates in the calculation of the geometry and the position of the elements of the document. Because reflow is a user blocking operation in the browser, it's important for the developer to understand how to reduce it. So, for example, in a React applications, you have now the initial HTML page that is rendered, and then you now put the container where your React application is going to work. Uh, the app will be mounted, and then you apply some modifications to the DOM via the DOM API, and now this is how you actually are triggering is these updates. So the reflow is a multi-step process that usually is kicked out by GSS. Then the browser needs to recalculate the DOM and the CSS, and where it knows the position of the HTMLs and elements on the layout phase, like that, on the layout phase, because that layout, the style and the layout are CPU intense operations. It's important to understand that it can block the render threads for that, And then after the layout you have now is the paint, is how the browser is going to represent all of this bitmap on the screen. And this is something that is heavily used by the GPU. And last but not least is the compose phase. Is the composing phase. So switch to layout pane composite, which is now the unoptimized that. Okay. So the thing is that you're using is some of the CSS property or stacking context that now are GPU, that are now GPU. So for example, in this case, you must use is the transform for that. If you use now the margin top, it's actually a specific layout phase, which is calculating that, and the transform is creating a stacking context for that. So as you can see here, if we inspect that, and then we say, hey, I want to measure is the performance. Unfortunately, here we add in um, crown for that. I want to now take a look at this, and since they're using is now the optimized pipeline, you shouldn't use any CPU, as you can see here. But if you switch to the another one and you take another record, which is now using is this CSS class that are not using that. As you can see, because I have of course a lot of core, 16 core here. Of course, it's using a CPU, but you get the idea. Oh, give me a minute. wrong. Completely wrong. Exactly. The difference is small because now when it use the margin, the browser needs to calculate the positions of all of these elements, where now when we use transform, it creates when we use transform, it creates a stacking context that use the GPU instead of the that use the GPU instead of the CPU. hmm So we're now when we use transform uh, with with translate y, it creates a stacking context that use the GPU instead of the CPU because it is moving pixels. One is moving the elements and the other is moving pixels. Mhm. Talk about is the composition layer, bro. Mm-hmm. More than half megabyte. Mm, border image slice. Border image source. Border image slice. Mm, 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 mm. Border image source. Border image width. Border left color. Border left width. Border right color. But this is border right style. border right width as well. So for the top color, for the top left radius, for the top width, bottom, box shadow, and box sizing. Mhm. And the composite layers. Okay. Mhm. So how the browser use the GPU? Because so far we have actually looked at what are the properties that actually when we trigger what are the properties that allow us to create now stacking context that tells to the browsers to communicate to the GPU. Okay, for example, when you use transition, all right, uh, and now how the browser exactly now how the browsers use the GPU. How does the browser use the GPU? So how now why you telling then this is the instruction, this is the directive that I want you to make use of the GPU. Now, how the browsers use the GPU? All right. Okay. This is not the composition layer. Composite. Okay. Mm-hmm. the render object tree, the render object tree on MDN. Oh, because this is the render object tree. Okay. Okay. From the DOM tree, once it has that to okay. Mm-hmm. Mm-hmm. From the render tree, which is this, for the render tree, this is the way how now the browsers actually from the render tree create now uh, or know how to talk or how to work with the GPU, how to use the GPU. The render layer tree. Okay. And then it creates the CSS object model, the render tree. That's right. To construct the render tree, the browser roughly does the following. Starting at the root of the DOM tree, traverse each visible node. Some nodes are not visible. They're not reflected in the render output. Some nodes are hidden via CSS. To the layout stage, which is the way of how now the browsers determine the or the reflow, okay, which is now the way of how the browsers determine is the position of the elements and it is geometry. So it's creating now in a stacking context here on the exactly. It's creating a stacking context from the up from the containing element. Okay. Mm-hmm. Graphic layer and render layer is not affected because we haven't any do some transformations or CSS transformations or position rendering there. But we need to actually some data is the stacking context here, which is inline block. But this will be inline block to the container itself or to the closest, in this case, the to the element itself, um, which is the model, right? And here we creating is a new inline block. That's right. Formatting context. So all of these elements inside of the disk will be now be inside of that. And then when we run this, since this position absolute transform translate, so since this is now actually updating is a DOM tree, and then we creating is the element on the render object tree, that now this is changing the position of the element, which is creating a stacking context, which is added to the render layer tree. Uh, and since we are now using transform, which is actually the way of how do we talk to the browser and tell, hey, I want you to now create is a graphic layer here for these elements. These elements follow is the normal flow, which means is, or I mean, this element doesn't follow the normal flow. We put that absolute, which means is that it'll be attached to the closest position, to the closest pattern element, position relative, or the block, the closest block formatting. So in this case, this since this div actually follow is the block formatting context, but now it is position is at the closest position relative, or it is nearest block element. In this case, it is placed inside of the section here. No, I'm sorry. It's put it at the top of the HTML. It doesn't provide any size. Okay. Yeah, the stacking content that we end up with. Yeah, the stacking content that we end up with the n. And the stacking content one will be and then the stacking content 1 will be on top of that. The second one, yes, the transform. And then the stacking content will be on. And then the stacking 1 context will be right on the top of that. And the stacking content 2. In this case, yeah, and then the stacking content, and then the stacking context, and then the stacking content 1 will be on top of that. And then the stacking content 1 will be on top of that. No, the stacking context 2 will be on top of the stacking context. Jedi of Reflow. What in the F?
Okay.
That'll be all for this video. Take care. Bye bye.
Jesus.